Continuation of the exercise distance time and speed time graphs. Figure 1.1 shows a speed time graph for a vehicle accelerating from rest. So a speed time graph, you can see the slope is decreasing. So if a slope is decreasing, we can say the acceleration is decreasing. And then the speed is decreasing, but it is a straight line. So we can say it has a constant deceleration. The term deceleration means decrease in speed, and because it's a straight line, so constant deceleration. Calculate the acceleration of a vehicle at time equals to 30. Now, this type of a graph, as we don't have, like, because if you want to calculate acceleration or deceleration, it depends on what is the shape of the graph. It might be a straight line. If it is a straight line, then you have two possibility. You can use a formula or you can use a gradient. But if it is a curve, then what you have to do, you have to draw a tangent and then find the gradient of the tangent. So when we check this graph, a speed time graph at 30 seconds, so means this is the time is equals to 30 seconds. 10 boxes equals to 40, so each box equals to 4. So this is 24, 28, and 32. So between them will be 30. So when it is 30, it is like it is a curve. It's not a straight line. So when it is a curve, what you have to do, you have to draw a tangent. Length of a tangent, it's up to you, but you have to draw a tangent here, which should only touch that point which you mark. So we mark a point because we wanted 30 seconds. So we mark a point where time is 30. We mark a point and then we draw the tangent. After drawing the tangent, you can take any 2 points on the tangent. And the first point on x-axis, that is x1. The first point on y-axis is y1. The second point on x-axis, x2 and y2. So 2 boxes like are there. So this x1 is equals to 8. X2 is how much? 2 boxes. So it will be equals to 68. Y1, 10 boxes equals to 10. So each box is 1. So it is 6, 7, and 8. So Y1 is equals to 8. And Y2, it's equal to 29. So we use a formula of the gradient here, which is Y2 minus Y1 over X2 minus X1. So Y2 is how much? That is 29. Y1 is 8. X2 is 68. And that is 8. So when we simplify, this will be 21 and this will be 60. So 21 divided by 60, 0.35. So it's equal to 0.35 and the unit will be meter per second square. So, and these type of questions will have a range of answer. It's not like usually they have a range whenever you have to draw tangent. So for this question, the range is from 0.3 to 0.45. So we are getting 0.35 means we are getting a not the maximum answer or minimum answer, we are getting approximately an average of the two. Is it clear how we work out the gradient and how we work out the acceleration? Any doubt in this?
No, sir.
Okay. So if it is a curve, you have to draw a tangent. If it is a straight line, you can use a gradient. Like you can just take a gradient of that straight line or use a formula. Without further calculation, state how the acceleration at 100 second compare with a 10 second. Suggest in terms of forces why any changes are there. Look, first, when we compare the acceleration at 10 seconds, so from 10 second, when we compare, like this was 10, the angle, it was having a steeper angle as compared to 100 seconds. This is 100 seconds. So first, when you compare which part at 10 second, it will have a greater acceleration. At 100 second, it will have a smaller acceleration. And what happened? Because if acceleration is decreasing, so what happened to resultant force? The resultant force will also decrease. Or usually, because what actually happened, why the resultant force decrease? Because the resistive force increases, so the resultant force will always decrease. Because like this is an acceleration, speed time graph for vehicle is there. So why it's like in the beginning it was having a greater acceleration, but then as the speed increases, the acceleration is smaller. What is the reason for that? For example, if the driving force is 10 Newton here and driving force is 10 Newton, when it was moving at a speed of 5 meter per second, the resistive force will be smaller as compared to when it is moving at a speed of 25 meter per second. So when it is moving at a higher speed, the resistive force increases. Like here, resistive force might be 2, here resistive force might be 8. So what is the resultant force? The resultant force is equal to 8 Newton, but here the resultant force equals to 2 Newton. So when the vehicle accelerates, the resistive force increases. When the resistive force increases, the resultant force will decrease. So how we write this answer, like when we compare the acceleration from 10 seconds to 100 seconds, the acceleration decreases from 10 seconds to 100 seconds. And why it is decreasing? Because the resultant force decrease. And why the resultant force decrease? Because when the speed increases, the vehicle experience greater drag force or greater air resistance. So as a vehicle experience greater air resistance, that's why the resultant force is decreasing. Is it clear, this part? Why the acceleration is decreasing? Then determine the distance travel from 120 to 160. How we can find a distance travel from 120 to 160? So again, you have to use area under the graph. And you have to take total area under the graph. Like some student, they miss this part, like when they only take this part. That is wrong. You have to take total area under the graph, which is a triangle and a rectangle. So, or you can use a trapezium. So it will be half. Base is how much it is starting from 120 and ending at 60. So it is 40. And height is how much? 20 to 30. So it is 10. 400. So this will be 200. And this will be 120 to 60, 40. And the height is how much? 20. So that will be equals to 80. So this is 80 meter and this one is 200 meters. So when we sum them, we'll get because it is starting from 20 and ending at 30. So that's a triangle, half base into height. So which is 200 and then, sorry, this is not 80, 800 because I thought it was 2. It is 800. So total will be 800 plus 200, which is equals to 1000. So total distance travel equals to 1000 meter. Then a bus is traveling between the points A to D, and there are bus stops from A, B, C, D, but the bus does not stop at B and C. In a speed time graph is there. Describe the motion of a bus between each stop from A to B. What is happening from A to B? Speed time graph, the slope represents the acceleration. What happened to acceleration? Is it increasing, decreasing, constant?
Decreasing.
Decreasing, because the slope is decreasing. So if the slope is decreasing, so acceleration is decreasing. So that is why this is for the first one. Then from B to C, its speed is not changing, moving forward at a constant speed. So from B to C, it's a constant speed. From C to D, the speed is decreasing and it is having a constant deceleration. So from point C to point D, the speed, what happened to the speed of the bus? As you can see, the speed of the bus is decreasing. So it will have a constant acceleration because there is no option of deceleration. So that's why we mark constant acceleration. But it should be like option as a constant deceleration. Here it has a constant deceleration or negative acceleration, we can also say. Here there's a zero acceleration or speed constant, and here the acceleration was decreasing. Average speed of a bus from A to D is 32 km per hour. Calculate the distance travel. Look how much time the bus is taking to move from A to D. That's equal to 2 minutes. And the average speed is 23 km per hour. So we have the formula that average speed equal total distance divided by total time. Average speed equals to 23. Total distance traveled by the bus, we don't know. Time is in minutes. Like it was from A to D, it was taking 2 minutes. So we have to convert into seconds. So we have to divide. So we have to divide this 2 by 60. Sorry, we have to convert this minutes into hours because the speed is in kilometer per hour. So the time should be in hours. So 2 divided by 60. Which is equals to 0.016. And then 0.016 times 23. So the total distance travel will be equal to
Sir, time is 0.03.
0.03. Okay, sorry. It was 2 divided by 60. Yeah, 0.03. So you multiply, you will get 0.77 kilometer. Okay. 0.77 kilometer. That's a distance travel. Then a bus is stopped at D for 1 minute and then it travel at a constant acceleration for 30 seconds. On a figure, sketch the addition motion and label that as X when the bus start to accelerate and label Y for 30 seconds. So for the bus stops at D for 1 minute. So we have to show that the bus stop for 1 minute. How we represent, like stop for 1 minute means speed should be 0. So it stopped for 1 minute. Then travel at a constant acceleration for 30 seconds. And then sketch a possible graph for addition motion. Label X when the bus start to accelerate and label Y 30 seconds later. So at D, the bus stop for 1 minute. That is the first part. Then the bus after being at rest for 1 minute, then travel at a constant acceleration for 30 seconds. So we have to show that it was accelerating for 30 seconds. So it accelerate because 30 seconds means like half minute. So 3.5 minute it was accelerating. But they did not mention what speed it reached, so we can draw any line. And then the next part, label X when the bus start to accelerate and level Y for like 30 seconds later. We just have to continue this additional motion. So for X, what we will do, like first, there will be a horizontal line from 2 minutes to 3 minutes. Like for 1 minute, the speed is 0. And for 30 seconds, it continued to rise. So, and they did not mention whether it was like acceleration was increasing or decreasing. So we can draw any of them. Just we continue the motion for 4 minutes. Because, and label that when it start to accelerate, label that point as X and then continue that as Y. Is it clear, this one?
Yes, sir.
Anyone having a question or doubt?
No, sir.
Okay. Then question 14, a rocket is stationary on the launch pad at time is equals to 0. This is the acceleration time graph, not a speed time. It's an acceleration time graph. First, you can see the acceleration is increasing. The value of acceleration is increasing. And then the acceleration is constant. So if you want to sketch a speed time graph for this motion, speed time graph, the slope represent the acceleration. First, the acceleration increasing, like value of acceleration is increasing. So how we represent acceleration increasing? And then a horizontal constant acceleration expression is not changing. So it will be a straight line. So define the acceleration. The first question, define acceleration, increase in speed in a unit time. And on a figure 1.1, sketch how the speed of a rocket vary from 0 to, so this whole motion we have to explain. So like we have to just sketch the same on the same grid. So first acceleration was increasing. So for a speed time graph, how we represent an increasing acceleration? So we represent acceleration is increasing. And then acceleration is not changing, constant acceleration. So how we represent a constant acceleration? We draw a straight line. Is it clear, this graph? Because it was an acceleration time graph was given. This was an acceleration time graph, and we have to sketch a speed time graph from the acceleration time graph. At time 35, the airplane stopped decelerating and moved at a runway along a runway at a constant speed with a speed of 6 meters per second for further 15 seconds. On a figure, sketch shape of a graph, distance traveled by an airplane along, and you're not required to calculate a distance value. So first, the airplane stopped decelerating. Like first, it was decelerating. Distance time graph, what the slope represent? The slope represents speed. And deceleration means the speed decreasing, so slope should also decrease. So first we draw the slope decreasing, and then it move at a constant speed, distance time graph. The slope represent the speed, so it will be a constant speed. So it will be a straight line. So here the speed is decreasing. Here the speed is constant. And in question 13, a skydiver of mass 76 kilogram falling vertically in air. So what happened to the acceleration of a skydiver? Like here in the beginning, it is a straight line, so acceleration is constant, or deceleration is constant. But the angle is decreasing, so deceleration is decreasing. And at this point, the deceleration is 0. And why the deceleration is decreasing? Because the resultant force is also decreasing. Because the air resistance increased, so maybe he opened the parachute, so air resistance increased. Figure 1.1, determine the deceleration immediately after parachute open. So this is because when you open the parachute, its speed will decrease. So we want to determine the deceleration or change in speed in this part. And this part, it is a straight line, so we can use a formula or we can use a gradient. It won't make difference. So we can use a deceleration using a formula or gradient. So the starting speed, that is each 10 boxes equals to 20. So each box equals to 2. So this is 58. So starting speed U is 58. This is speed equals to like 24. This is 36. So speed at this point, the final speed is 36. And what is the time interval? How much time he took? So it is 1, 2, 3, 4, 5, 6. So 0.6. So final is 36. Initial is 58 and divided by 0.6. So it will be minus 24 divided by 0.6. What's the answer? Minus 24 divided by 0.6. 36. So the deceleration is minus 36 meter per second square.
Sir, why did you choose 36 as the final speed?
Why I choose 36 as a final speed? Because after that, the speed is not changing with the constant rate. In the question, they ask calculate the deceleration immediately after you open the parachute. The moment you open the parachute, the speed was changing with a constant rate. But then what happened? The change in the speed is not constant, like it is getting curved. So the last point where I was having a straight line, that point was actually like, even like if I choose this region, I will get the same answer. Say this is equals to 58. This is 3 boxes are there. So this will be 34. And the time interval has changed now. So time interval is about 1, 2, and 3. So this will be 0.7. So when I work out, it will be change in its speed like final minus initial. So 34 minus 58 divided by 0.7. So approximately same answer I will get. Is it clear? Because they asked for initial, and this is a part where initially it was decelerating. Then the deceleration is decreasing. That's why we have to take different value. So this was question number 13.